Hello all. We know that Earth is one of the planets of the solar system. So all the planets of the solar system will be having two motions. One is the rotatory motion and one is the revolutionary motion around the sun. Likewise, Earth also possesses two motions. One is the rotation and second one is the revolution around the sun. In our today's class, we are going to discuss these two motions and what are the effects of these two motions. So, our today's class is rotation and revolution of the Earth. Now, let us discuss what is rotation. In your previous classes, we must have studied what is rotation. Rotation is the motion of the Earth around its own axis. Axis is anything or any point on which anything rotates on itself. So, anything is rotating on itself is known as the axis of that point, right? The Earth's axis is not straight. Earth's axis is not straight. It is tilted to an angle of 23.5 degrees or 66.5 degrees to the plane. This is the Earth's plane. So 23.5 degrees or 66.5 degrees to the plane. Right? So this motion of the Earth, in short, is known as the rotation of the Earth. We have another motion of the Earth, that is the revolution. So this is the sun and this is the elliptical orbit in which the Earth moves. So this is the Earth. So when the Earth moves in an elliptical orbit, this motion is known as revolution. All planets will be moving in an elliptical orbit. And why planets will not be falling down is we have two types of forces acting upon. One is the centrifugal force and one is the centripetal force. Because of these two forces, there will be an attraction between the planets and the sun. So that attractive force will be keeping the planets intact in the orbits, right? The speed of the Earth is different at different places. Take for example, the distance near the equator is more than that of the poles. Pole is only a point. So the distance at the pole is 0. The distance at the pole is 0, whereas the distance at the equator is maximum 12,756 kilometers. So this maximum distance covers a maximum speed because the distance here is 0. The distance at the poles is 0. We know the formula for speed is equal to distance by time. Formula for speed is equal to distance by time. Now we are substituting here the distance 0 by time. That is why the speed at the pole will be 0. The speed at the pole will be 0. So here we have the movement of the Earth very slow. Since the distance here is more, we have the rotation of the Earth at a faster pace near the equator. Clear? So near the equator, this 12,756 kilometer, the equatorial diameter is covered at a speed of 1600 kilometer per hour. 1600 kilometer per hour. So this is the speed of the earth at the equator. At the equator. At the poles we have seen it is 0 kilometer per hour since the distance is 0. So we have substituted speed is equal to distance by time. Distance is 0. 0 by time is again 0. Right? Now let us see about the Earth's axis. Earth's axis runs from the North Pole to the South Pole. North Pole to the South Pole. This is the Earth's orbital plane. Earth's orbital plane. And this is a vertical line drawn from the Earth's orbital plane. This is the vertical line drawn from the Earth's orbital plane. Now the angle which is made from the Earth's orbital plane to its axis is 23.5 degrees. Earth's orbital plane is 90 degrees. Total 90 degrees. So the balance angle is 66.5 degrees. So we can either say that Earth's axis is tilted to an angle of 66.5 degree or 23.5 degree. Okay. So this tilt of the Earth's axis is also known as inclination of the Earth's axis. Tilt of the Earth's axis is also known as inclination of the Earth's axis. Because of this tilting only, we are having seasons and we are having unequal days and nights. For example, if the earth is like this, if the earth is not tilted like this. Now, let us imagine the earth is tilted like this. Now, if this is the sun, now so many places on this side will be having days, daytime, but the upper portion will be having is away from the sun, so they will be experiencing little night time, and this part also will be experiencing daytime only, right? So they will be having unequal days and nights. Though this is on one side, they will be experiencing unequal days and nights, right? And seasons are also caused because of this tilting of the Earth's axis. Seasons are also caused because of the tilting of the Earth's axis, right? You'll see how seasons are also caused because of this tilting. Now, let's move on to rotation. The Earth rotates on its own axis, and it takes about 24 hours to rotate on its own axis. So this line, which is demarcating the sun, is known as circle of illumination. Here, this line which is demarcating is known as circle of illumination. So illuminating means where you will be having light and where is the darker side. So here we can very clearly see this portion is having sunlight and this portion is a dark side. So from this picture we can understand that we are having unequal days and unequal nights. If this, according to this circle of illumination, if the plane, if the earth is rotating according to the vertical line of the orbit, then we will be having equal days and equal nights, but here we are having unequal days and unequal nights, right? The earth rotates on its own axis from west to east. Normally, we feel that the earth is moving from east to west. No, the earth is rotating from west to east on its own axis. And we have seen that the speed of rotation differs from place to place. At poles, the speed of rotation is 0. The reason is we have seen that the distance at the poles is 0. That is why speed of rotation is 0, and in the equator the speed is maximum because the distance is also maximum, right? So the speed keeps on differing from place to place. Clear? Right. What could be the effects of rotation? Okay, very good. The earth is rotating on itself. Now, what could be the repercussions of earth's rotation? We know the first outcome of earth's rotation is day and night. Every day we see day, every day we see morning, and every day we see night. What is it for? By what is this caused? This is caused by the rotation of the earth. Okay, this is caused by the rotation of the earth. Earth is constantly moving on itself. Earth is constantly moving on itself. Earth is constantly moving around the sun. So obviously this unstopping movement of the earth, motion of the earth causes the first effect of this is day and night, right? The second one is Coriolis force. Coriolis force means, take for example, this is the equator, 0° latitude. So this Coriolis force means it shows that all the ocean currents and winds, they keep on moving to the right of their course in the northern hemisphere and to the left of their course in the southern hemisphere, causing a circular motion. Here you can see a circular motion. So these are moving to the right of their course, and in the southern hemisphere they are moving to the left of their course. All winds and ocean currents, they are moving to the left, and here all winds and ocean currents, they are moving to the right. Okay. So this kind of movement is known as Coriolis force, and this is given by a law called as Faraday's law. Farrell's law. And the next one is east-west movement. East-west movement means we have seen that Earth is moving from west to east, but we feel that, see, normally we feel that the sun is rising in the east, right? Feel that sun is rising in the east. That is known as east-west movement. Normally when the train is moving very fastly. The train is moving very fastly. We feel that train is stationary and all the other things are moving very fastly, isn't it? So here also, this east-west movement shows that Earth is not moving. Earth is moving from east to west. Everything is, Earth is not moving from west to east. It's not moving from west to east. It's moving from east to west. The opposite is happening. That is what we feel. Right? Now here we see different positions of the sun in different months. Starting from January here, we have two equinoxes. We have two solstices. We'll see what are equinoxes and what are solstices, but this movement of the sun on different months, in different positions of the earth. So, one time it will be on the equator, two times it will be exactly on the equator, and two times it will be on Tropic of Capricorn and Tropic of Cancer. So exactly on Tropic of Capricorn in December, exactly on Tropic of Cancer in the month of June. The other 2 months it will keep on moving. It will keep on moving. So this movement of the sun on the earth is known as apparent movement. Apparent movement of the sun. Here, so we can see two exact positions on the equator, one exact position on the Tropic of Capricorn, one exact position on the Tropic of Cancer, and as it is moving from Tropic of Cancer to the equator, the movement on different latitudes. So this movement every month is known as apparent movement of the sun. When the earth is revolving around the sun in a fixed elliptical orbit, then this motion of the earth is known as revolution. As the earth takes 24 hours for its rotation, the earth takes 365.14 days for its revolution period. There are different revolution periods for different planets. The reason is the distance of the orbit changes. For example, Pluto has a revolution period of more than 10 years. Whereas Mercury, it is having the smallest orbit. So the revolution period of Mercury is only 58 days. So, the revolution period depends upon the distance of the orbit. Right? Just like in rotation also we have seen the speed of different places depends upon its distance. Here also the distance around the sun depends upon the distance of the length of its orbit. Earth's orbit will be taking this time period of 365.14 days. The speed of revolution of the earth is 107.2 kilometer per hour. 107.2 kilometer per hour. Okay. The distance of the sun from the earth is approximately 147 to 152 million kilometers. 147 to 152 million kilometers. We can see an elliptical orbit of the earth around the sun. So sometimes the earth is very near to the sun and sometimes the earth is far off from the sun. When is the sun very near? When is the earth very near to the sun means in January the earth is very near to the sun. In January the earth is very near to the sun, and this position where the earth is very near to the sun is known as perihelion. Perihelion. Peri means near. Helios means sun. So in January, where the earth is near to the sun, that situation is known as perihelion. And in July, the earth is far off from the sun. On July 4th, the earth is at its maximum distance from the sun. So that time earth is at aphelion. The earth is at aphelion. Now let us see what are the effects of revolution. The first effect of revolution is changing of seasons. We have different seasons because of revolution. The position of the earth keeps on changing. Take for example, this is March, June, September and December. We have 4 months, and here the sun rays fall directly on the equator. Sunrise fall directly on the equator, so it will be an equinox. Here, the sun rays fall directly over the Tropic of Capricorn. Sun rays fall directly over the Tropic of Capricorn. Here, the sun rays fall directly over the Tropic of Cancer here, and sun rays fall directly over the Tropic of Capricorn here. So here it will be spring equinox in the month of March in the northern hemisphere, and here it will be summer solstice in the month of June in the northern hemisphere. So we are taking everything with respect to northern hemisphere. Okay, here it will be spring equinox. It will be spring here in the northern hemisphere, right? For us it will be spring in the month of March. For us it will be summer in the month of June. So it will be summer solstice. Again it is an equinox here. So vernal equinox. It will be autumn for us. It will be autumn for us. So it is vernal or autumn equinox. So all these are with respect to northern hemisphere. And in December we have winter. So it is winter solstice. So we have change of seasons. We have change of seasons when the earth is changing its position. When the earth is changing its position, right? So this is the first effect. Second effect, we have introduction of temperature zones. Introduction of temperature zones. Why? Because when the earth is moving, the angle of heat is different from one place to other. See here, this place is very hot. This place is very hot. So we have the introduction of torrid zone, frigid zone and temperate zone. As the earth is moving, we have the introduction of torrid zone, frigid zone and temperate zone because of revolution. And obviously when earth completes one full revolution, we consider this as one full year. See, sometimes will be one full year means 365 1/4 days, no? That 1/4 days after 4 years we will be getting one leap year, right? After 4 years, February will be considering as 29 days, right? So this leap years also, this after 4 years we will be considering it as a leap year. Now let's see how the inclined axis is showing a unequal day and showing a impact on unequal day and night. So this is the inclined axis, north pole to south pole, 90 degrees north to 90 degrees south. And this is the equator, 23.5 degree north, that is the Tropic of Cancer. This is the Tropic of Capricorn. Antarctic Circle, Arctic Circle. So here this is inclined. Normally if it is straight, this would be the north pole and this would be the south pole. This is how it would be. If we would have having a straight axis, not an inclined axis, all parts on one side would be dark and all parts on one side would be straight away will be having this side would be darker and this side would be having light because this is the sunlit side. Now see here, because we are having sun here, this part, this is the circle of illumination. This is the circle of illumination. So this part is having sunlight and this part is a darker part. And this is still and some parts of northern hemisphere are dark and some parts of southern hemisphere are bright. Some parts of northern hemisphere are dark and some parts of southern hemisphere are still getting. See here, in the northern hemisphere we are getting darker parts. So, and in the southern hemisphere we are getting brighter area. So, here we are having unequal days and nights. Unequal days and nights. So, this is one impact of tilted axis. One impact of tilted axis. Now coming to the topic of solstices. On 2 days of the year, we have the longest night and longest day. So this longest night and longest day is known as a solstice. For example, we are having a longest day. Then that is known as a summer solstice. Then that is known as a summer solstice. Generally on June 21st, we will be having in the northern hemisphere, we will be having the longest day. So that day where the sun falls directly on the Tropic of Cancer, so that day we will be having the summer solstice. We have seen the apparent movement of the sun, right? 2 days it will be falling directly on the equator, and 2 days it will be falling. One day out of those 2 days, one day it will be falling directly on the Tropic of Cancer, and one day it will be falling directly on the Tropic of Capricorn. So where it will be falling directly on Tropic of Cancer in the northern hemisphere, that day will be having the longest day. So that day is known as summer solstice, right? So solstice means if the length of the day or night is more than the other, then we term it as solstice. Now coming to what is an equinox. Nox means night. Nox means night. Equi means equal. Equi means equal. So equinox means equal nights. So when you are having equal nights, you will be having equal days, right? So equal nights and equal days is an equinox. 2 days of an year when the sun directly falls over the equator, then we will be having equinox, right? So when we have seen the apparent movement, we have seen 2 days, the rays of the sun will be falling directly over the equator. Then we will be having equinox. On March 21st and September 23rd, we will be having a equinox time, right? So in March and September, the sun rays will be exactly falling over the equator, and we will be having equal nights and equal days. Here also equal nights and equal days, right? So here in the month of March, we will be experiencing, northern hemisphere will be experiencing spring. So we term it as spring equinox. Here again in the month of September, we will be experiencing autumn. So we are terming it as vernal or autumnal equinox. Again here in the month of June, the sun rays fall directly over the Tropic of Cancer. Sun rays fall directly over the Tropic of Cancer. So we will be having a lengthier day than the southern hemisphere. The northern hemisphere will be having a lengthier day than the southern hemisphere. So it is termed as summer solstice in the northern hemisphere. Here in December, the length of the night will be more. See here, the northern hemisphere is away from the sun. The southern hemisphere is near to the sun. So the length of the night will be more, so we term it as winter solstice. The northern hemisphere terms it as winter solstice. Now coming to the characteristics of each one. So this part the Arctic Circle will be having continuous daytime, continuous light. Okay, that light will not decrease all that 6 months. Okay, all the 6 months, and here in the at the poles you will be having continuous light. So in places like London and US and all, as you are experiencing this summer solstice and all, it's a very common phenomenon that we see lot of light, right? Why do we see lot of light in the higher latitude? Is the reason is this only. There the speed is very less, the speed of the earth is very less, so obviously you find lot of light in those places. And places which are away from the sun, places which are away from the sun, they are in continuous darkness. For all the other 6 months they are in continuous darkness. For example, it is in the northern hemisphere, no? So places in the southern hemisphere, they will be experiencing continuous darkness. Now on December 22nd, the sun rays are falling directly over the Tropic of Capricorn. Now see here, this part, the northern hemisphere, mostly it is in darkness, and the southern hemisphere, it is like this is 23 and a half, 66 and a half, right? So this part is in bright, the sunlit side, and this part is the darker side. So after 23 and a half, the 66 and a half and 90 degrees, they will be in continuous sunlight, and this part, the northern hemisphere, the northern side will be in continuous darkness for 6 months. Near the northern pole and Arctic region, they will be in continuous darkness for 6 months. So both on March 21st and September 23rd, the sun rays will be falling directly over the equator. So here, when the sun rays are falling directly over the equator, the circle of illumination will be exactly, the line is passing through the circle of illumination. So here we will be having equal days and equal nights. Circle of illumination is passing through the axis, right? So we will be having exactly equal days and equal nights, right? Both the days on March 21st and September 23rd. On March 21st we will be having spring, so it is known as spring equinox. On September 23rd we will be having autumn, so we are terming it as autumnal equinox. So to sum up once again, we have seen what is rotation, what is revolution, what is the solstice, and what is a equinox, and what are the effects of rotation, what are the effects of revolution, and what are the characteristics of rotation, solstices and equinoxes in this